Right, so good morning, welcome back. We have 3 weeks left until the Easter break, and then we have a couple of weeks after that in order to work before the end of the teaching block. So what I've decided to do, checking on the progress of some of the students last week in the lab, I noticed that quite a few people were moving ahead beyond the progress, the weekly progress of the material as I deliver it. So I decided to combine both the lab sheets for this week and next week, deliver them both to you, explain them, so that you can move on at your own pace even better, because it seems that you are moving faster. This way, I can deliver the OVS lab sheet next week, because that should really take you 2 weeks to do. And then when you come back after the Easter break, you should theoretically try to have a go for about a week at the last lab sheet. The last lab sheet, which is building the cloud, I don't expect most of you to actually get to it. It would be great, and I'm very hopeful seeing the progress that some of you have made in the labs, that you will actually get to it and actually build the cloud and everything. But as far as marking goes in the logbook, it's not worth too many marks. And definitely, you will still be able to get more than 70%, even if you don't even touch the last lab sheet at all. Okay, so just keep that in mind when you're working. All right, the last very important lab sheet for you to do is the OVS lab sheet. So that's why I've decided to move the lectures a bit forward, deliver both of them so that I give you more time to work on OVS, having known all of the parameters about it, and me having it explained it here. I will also, in the 2 weeks from now, so the last week before Easter, I will explain the last lab sheet. So if you are really keen, if you're in Portsmouth, or if you want to connect remotely and work, you could actually have a go at making as much progress as you can on your computers, so that when you come back after the Easter break, you can possibly have a better chance at completing the final lab sheet as well, definitely making sure that you get the obvious lab sheet out of the way. Now, there is a special consideration for when we're coming back after the break. If we go on to look at our calendar, so we have 1, 2, 3 weeks before the Easter break, then we have 3 weeks of Easter, and then we have 1 week, which is the end of April, that you all are in the lab. All right, and then we have 2 more weeks of teaching after that. However, we have the problem that both those weeks are bank holiday weekends, bank holiday Mondays. All right, so the people on the Mondays will not be able to get this lab session. Okay, and also the problem is that the next week, which really is going to be the assessment week, and it will eventually show up on your timetable, you won't be able to come in on a Monday to be assessed. Okay, so if you are on a Monday group, I will have to move you on a Wednesday afternoon. So it will be at exactly the same time as your lab sessions are, all right, but it will be on a Wednesday. I really apologize for this. There's no other way around it. Okay, if you look at the timetable, it's really horrible. So if you do have some sports events that are going on, because it is Wednesday, I am sorry. Unless it's like a game, a match, or a race, or something that's really important, and you have to be there, and it's not just some practice, then I would ask you that you just skip it that week. Okay, I will send an email to everybody about this as well. So this will all be in writing, and I will schedule everything so that it shows up on the timetabling. Okay, but it's 2 bank holiday Mondays in a row at the last 2 weeks of the teaching block, which is a disaster for us. Yes, and my timetable, unfortunately, normally looks like this. So Thursday afternoon, I think some of you have a class, so I cannot bring you in Thursday afternoon. And the lab, I think, is also not available. I think Yannis is running a class there, possibly with some of the second year students as well. So it's a horrible timetabling issue for me. Okay, so the best solution I can come up with is Mondays students come on that Wednesday afternoon. All right. So I will send you all of this on an email, and if somebody does have a stupendously serious problem with this, then just let me know, and I'll try to sort out another date, time that you can come and basically do the assessment with me. All right. There is the alternative as well that I could try and get some of you, if you cannot actually make a Wednesday, on a Thursday morning, if you don't have any other classes. That would simply mean that you would have to come in on a Thursday morning with the Thursday morning group, okay, and you would just have to wait for me to assess the person that's actually working on your computer on a Thursday morning, and then you can have a seat on our computer and work as well. Okay, so it's a bit of a logistical nightmare, but you know, we'll figure it out. Okay. So as for the material, so the next lab sheet that you have is the VM creation in Sandstone. So the first lab sheet in Opennebula that we did was the installation of Opennebula onto your Prometheus VMs. This means that by the end of this lab sheet, you should have the cloud software installed, and it should be running successfully. You should have the one admin user created, and you should be able to query that user with the one admin show, with the one user show command, and it should come back and say, yes, that user exists, you know, it has a home directory, it has a password, yada, yada, yada. Now, past that point, we need to do some more configuration, and we need to be able to build our first virtual machine in the cloud. Now, in order to do this, all of the required infrastructure needs to be in place. What needs to be in place for a virtual machine to run in the cloud is, first of all, we need to have a network. So we need to have the networking connections that we need to use. You can read everything, yes? Okay. We need to create a host, so a host that is capable of running virtual machines in your cloud, for your cloud infrastructure. We need to have the data storage in place, so the physical hard drive storage space for everything that we need to be stored in it. And we need to have an image or a few images for our virtual machines. We need to have some templates that will basically configure all of the characteristics of the virtual machines that will start in the cloud. And then after that, we can start up the virtual machine in the cloud itself. These steps all pretty much depend on one another. So it's like a pyramid. So they need to happen in the correct order, and they all need to be executed correctly and be running correctly before you move on to the next step. So be careful about this when you're progressing with the lab sheet. So the first thing that we need to do is we need to create some custom networking. So at the moment, your Prometheus virtual machine should have an ENS33 network card that is bridged and connected onto subnet 28 and through that to the outside world. What we need to do is we need to create an interface that's called BR0. So that will be a bridged connection to the outside world, and it will be a bridge that will basically connect us through the ENS33 network card onto the outside world. To do this, we'll do this by going completely manual on the network configuration in our system. So we'll need to basically go into our etc. sysconfig network scripts folder and alter the configuration files that we have in there for the network cards in our system. The first file that we need to change will be the IFCFG ENS33. So that will be the file of the actual main network card that we use in our system. So all you need to do is you need to tell it that it's going to become a bridge, and it's going to be bridged to network card BR0, to device BR0. The boot proto none statement means that, you know, we don't need to configure this network card when it starts up. The nm controlled equals no is very important, because that's network manager controlled equals no. This means that this network card will disappear from the graphical user interface that we have in our operating system on the top right corner next to the clock. So when you try to go onto the network cards there, it will not show up there, because we've told the system not to control this network card through the network manager. It will start up at boot time, it will be in type Ethernet, and it will be connected onto the bridge BR0. The bridge BR0 we will have to create, okay? And we'll do that by creating a new file from scratch. If you type the command gedit, etc. sysconfig network scripts ifcfgbr0, it will create that new file. And then all you need to do is copy and paste the contents of this file from here onto that configuration file. Of course, the red letters need to disappear and the question marks there need to be replaced with the IP address of your Prometheus virtual machine onto your bridged network on subnet 28. So this should be the IP address that you had before for your ENS33 network card. We're just moving that IP address exactly with all the same characteristics onto the BR0 interface now. Because then we can connect and we can manipulate that BR0 interface as we like, and we can use it for our cloud. Once you do that, you restart the network service, then your ifconfig should show you an ENS33 network card that's blank. It should show up there, but should have no IP addresses, and it should show you a BR0 network card this time as well, which should have all of the networking information that ENS33 used to have before you do this. After that point, we go on to adding a host. So before we add a host onto the system, we need to make sure that Opennebula and Opennebula Sandstorm are actually running. And for peace of mind, we need to make sure that they are running automatically every time we start our computer. So all we need to do is basically type these two pairs of commands so that we start the services and we set the services to start automatically at boot time. After that, you need to go into the Sandstone interface, you need to go into infrastructure and go to hosts, and some of you, definitely the people that are in on a Thursday class, will already have this host there. Okay, most of the people on the Monday class should have it as well. Alright, this is because on the first week of the labs, we had to make a change on the Prometheus virtual machine. So on some of them, I actually went ahead and performed some of the steps. So most of the steps of the first lab sheet will have already been done on your computers. And as such, on the second lab sheet, I went up to the point to making sure that the host, the visualization host in the cloud, is actually there and it runs. So, two scenarios. Either this will be blank, in which case you follow the instructions here. You add the host name. Remember, when you add the host name, it needs to be the fully qualified domain name. So it needs to be prometheus.netlab.e.port.dc.uk. All right. Or the second scenario is that you go there and the host is already present and its status is on, it's running. So you don't need to do anything. Just take a screenshot of it, say hooray, and move on. All right. Once you have, if the host doesn't start, if it says error, there's two choices. Either you've typed the host name wrong. So the one way to fix this is to go onto a terminal, type host name, and whatever comes up, copy and paste it into the new host dialog so that you make sure that the host name is exactly as it appears on your computer. Or you've made a mistake on the previous lab sheet in the passwordless SSH step, and passwordless SSH doesn't actually work. Okay, for this visualization host to turn on, Opennebula needs to be able to contact it without requiring a password to SSH into it. So this means that if you made a mistake in that step, then the system, the Opennebula service, will not be able to actually communicate with your visualization server. All right, so either hostname or SSH. If you can't figure it out, call us and we'll come and have a look at it and try and fix it for you. If it's on, you move on to the next part, data stores. You should need to do nothing for this step. You should just go into storage, you should go into data stores, and just verify that you have 3 data stores that are present there. This is a system default setting. If the installation of Opennebula was correct, you should have 3 data stores present there anyway. Okay, just make sure that they're there, get a screenshot, move on to the next part. Adding networks. You need to go into the Networks tab and you need to create a new network card inside the cloud that will connect onto the BR0 network card bridge that you just created using the config files on your host itself. Okay, follow the instructions here. The only thing that you need to be careful about is the IP address that you need to give to this. The IP address you need to verify and check with us. Just like you did in your VMware and VirtualBox for that second bridge network card on VP1 and VP5, you need to use that IP address. If you're unsure about which IP address to use, then just ask us and we'll tell you which address to use. The general rule that we use is if you're sitting on a computer that has an address of 28.65, then your Prometheus address is 165, and then the second bridge address in here should be that plus 50. So if you are on 65, that will be 215 or whatever it is. Yeah? That rule, if you're sitting on one of the higher addresses, will not work. It will take you beyond 254 that you can use. So you need to ask us, and we'll probably give you one that's minus 50 rather than plus 50. Okay. Either way, if you go back to your previous lab sheets, in the VMware and VirtualBox lab sheet, it should be the same IP address that we allocated to you for those lab sheets as well. Once you have the network card in place, you can start adding images. The images are the hard drives that you will use for your virtual machines in the cloud. In our example here, for the simple virtual machine that we're creating, you will create 2 images and they are of different types. The first image that you will create will be called vPrometheus 0, and it will be a blank hard drive for your operating system. You need to give it 10 gigabytes of space. You need to set the file system to QCOW2, which is a specialized file system that we use for Opennebula. And then the other important option is that you make sure that you set this to persistent. Persistent means that the contents of that hard drive, once they are changed, they stay there. You need this because you'll be installing an operating system in this virtual machine. So you need to make sure that once you do the installation, it doesn't get deleted. It stays there. All right. And any users that use this virtual machine later on, when they work on it and they save some data on their home directory, the data actually stays there and doesn't get deleted. Okay. So persistent hard drives in the cloud mean that any changes you make to them, they stay there. The second image that we'll create will be a CentOS DVD installation image. So we'll set it as a read-only CD-ROM drive or whatever the option is called in Opennebula, and you need to connect it to the image of the CentOS ISO that exists on your hard drive already. It will upload it, it will take a while. Make sure that before you try to use it later on in the templates, it's actually turned onto status ready. Okay, so don't leave this page before both of your images are showing up as ready in the cloud, ready to be used. Once you have your images in place, you can then create a template. A template is a guide of what your virtual machine in the cloud will actually use. Which images as hard drives, which network cards, what computer name, what CPU architecture, how many CPU cores, how much memory, and so on and so forth. Okay, so it's like you have all of the ingredients for the recipe ready to use, and the template is the actual recipe that tells you how to use everything to create that VM. In our case, we'll make a simple VM. It will be based on a KVM hypervisor, because that's what we're using by default, and that's what Opennebula uses by default. We'll give it 1 CPU, we'll give it 2 gigabytes of RAM, we'll give it the 2 images for the hard drives. The first hard drive should be the Prometheus hard drive, and the second image should be the CentOS DVD. And then once you do that, you need to tell it that it's an architecture of x86 64-bit, and it's KVM based, and you can connect to it with VNC. So all of the options are there in tabs, so you have to go through different tabs for your template, and once you've answered and checked all the boxes in all of your different tabs, your virtual machine will be ready. There's one point in this that is very important, and that's when you actually configure which hard drives, which images your template needs to contain, you need to not only select the boot order, so it should be correct, so it should start from the hard drive first and then from the DVD. You also need to make sure that you check the boxes on the left side of these hard drives in the GUI, in the website. Okay, if you don't check the boxes, you're not actually selecting the hard drives to be used, so your virtual machine will not boot. It will just start up on a black page, and that's it. Okay, so be careful about that. Make sure that you check the boxes next to the hard drives. Once you do all that, then it's time to start up your virtual machine. Now, virtual machines have various different states in the cloud. And the first and initial stage of a virtual machine in the cloud is to create an instance, a running instance of this virtual machine in the cloud. This means that we take a template that we have in there and we instantiate it. Okay, so we make a running instance of that virtual machine according to the characteristics of that virtual machine that we have in the template that we created. So when you instantiate the virtual machine, it will show up in your running VMs section of Opennebula. The first thing that will happen is it will get an IP address. And the second thing that will happen is it will get allocated to a host, to a virtualization host, which is yourself, on the computer that you're actually using. So once the virtual machine starts up, it will take a while to actually show us running. All right, so it will go through various stages of actually being able to run. And this takes time for the simple reason that the images that we're using, the DVD and the hard drive, need to be copied from the images data store into the system data store, which is the running data store that basically contains the images while they're running on the system. Okay, this is done for redundancy and security purposes, so it might take up to 3 or 4 minutes for the virtual machine to actually show up as booting and then running. If it's running, a little blue icon will appear next to it. You can click on it, and that will be the VNC connection that will take you to the virtual machine that will open in a second tab inside your browser. And once you go into that tab, you should be able to get a view of the virtual machine as it's running, and you should be able to install the operating system inside it. The installation of the operating system is pretty basic. You need to accept everything as default. The only change that you need to make, and it's important, is in the software selection section, you need to set the virtual machine as a known desktop. If you don't, by default, it will do a minimal install, which is all great, but you'll just end up with a virtual machine that is just a terminal on run level 3, and you don't want that. Okay, technically it is a virtual machine, and it works. Practically, you can't do anything with it. All right. So, very important, make sure that you choose the known desktop for that virtual machine. Once it's built and it's running and you can log in, you can create your user, but always log in as root again. You basically have your first virtual machine in the cloud and you're ready to play around with it and see what you can actually do with that. Which brings us to the second lab sheet for today, which is familiarization with Sandstone. Now, because Sandstone is the main interface that you will be using for the cloud in order to be able to manage all of your virtual machines and all of your resources in the cloud, you basically need to know how to use it. Yes, it's not necessary to know this. You can manage your entire cloud on the command line interface. Okay, and lots of people do because it's much more efficient. This would just mean that you need to learn quite a few commands in order to do this. All right, so we don't have the time. I won't say the patience, I'll say the resources to get you all to learn all of the commands and try to get you all running everything in command line. So we'll be content for now with you using Sandstone to manage your cloud. So there are 3 different views that you can have in Sandstone. So there is admin, VCC admin, and the Opennebula cloud user. The admin view is what you've all been using so far, because you've all have been logging in as one admin. It means that you are the top level administrator of the cloud itself. Later on, for example, in the last lab sheet, you would create a new virtual data center, so you can split a big cloud into multiple smaller virtual data centers. So, for example, if you were Amazon.com, then the one admin user would be the top level guy that can do absolutely everything on Amazon's cloud infrastructure. Yeah? If you're a VCC admin, it means that you've rented some cloud space from Amazon and you have administrative rights for that particular cloud space. So you have a set number of cores, a set size of hard drive space, some memory, some network infrastructure in place, and you can use all of this to create your little virtual data center, your little sub-cloud inside that cloud infrastructure that Amazon provides, and you can manage it and use it for your company itself. And then in the end, you have the simple cloud user which is the end user of the cloud, which will be either your customers or the personnel in the company that you're working for. And there will be the end users that can have, the lowest amount of rights. They can basically start up virtual machines, use them, and then stop them and go home. And that's it. All right. So we'll explore all of this. So looking at admin view first, the virtual machines that exist in the cloud can exist in various states. And all of those states depend on whether the virtual machines are running and they are available for users to start, to boot up and use, or whether they are actually loaded inside the cloud and are being used or not, or whether they are not actually loaded inside the cloud at all. So you can have a virtual machine that exists as a template in your cloud, but it's not loaded as a running instance, so nobody can actually do anything with it. You can have that virtual machine loaded as an instance, but not running. It can be powered off. You can have that virtual machine running and being loaded as an instance as well. You can have it suspended. You can have it suspended and sent back into the data store so that it's not taking up any space in the cloud itself, and so on. So play around with the different states that you can have. Play around with the power buttons, suspend, power off, and so on. No matter what you do, the virtual machine itself will not be deleted, so don't worry about it. Even if you click on the red button that says terminate, the virtual machine will go away from the cloud currently running, but it doesn't mean that you've deleted the installation of the operating system that you've just made. Okay, the template will exist, the hard drives are persistent, so the installation will stay there, so everything will be in the image itself. So then if you load up and instantiate that template again for even another user, then all of the contents will still be there. Okay, so don't be afraid to do whatever you like with the virtual machines, as long as you don't delete the actual images themselves from the storage area, then you will not lose the progress that you've made for your virtual machine in the previous labs. Okay. I would like you to play around a little bit and see what actions you can actually take with your virtual machines. So for example, you can create a new hard drive, give it like 100 megabytes of space, something very small, and you can attach a hard drive while the virtual machine is actually running and instantiated in the cloud. You can also remove it as well, and you can do the same thing with the network card also. So you can create a new network card, call it John, whatever you like, it doesn't really matter. Give it any IP address, give it an IP address on a private network, 192.168.0.1. It doesn't matter because you won't use it. I only want you to create it so that you can actually see that you can attach it and detach it onto the virtual machine while the virtual machine is actually running live. And the funny thing is that with network cards, for example, you'll see the network card actually appear in the operating system a few seconds after you attach it to the virtual machine. So that's pretty cool that the OS actually detects that straight away. Yeah, so it will give you lots of flexibility on what you can actually do with the virtual machine itself. You can take snapshots of it, so you can try this if you like. Take a snapshot inside Opennebula as well, so that you basically keep a backup of the virtual machine, and you can try to resize the VM capacity for the virtual machine. So you can give it one more CPU core or 2 more gigabytes of RAM and so on. So play around a little bit with this. See what works and what actually doesn't, and if something doesn't work, then try to figure out why, so that you experiment with it. One very, very important bit is the permissions, because you will be eventually creating more users, more user groups. You need to make sure that the permissions on all of your resources are set correctly. The simplest and most bulletproof way to set everything up is according to this. Okay. So everybody can actually use the image, but only the owner can actually manage an image. So you can apply these permissions to the images, to the templates, to the network cards that you create in your cloud itself. I would then like you to create a group, and you can call the group students. And it's very important that you create a student admin user for that group, so that's on a separate tab, so be a little bit careful about this when you do it. Okay, so you can create a new user that will automatically create an admin user for that group, so that admin user will essentially, for all intents and purposes, be your VCC admin user, so it will be the person that can actually manage this entire group. Okay. And you can basically try and see what you can do with those users. Ideally, by the end of it, I would like you to be able, by the end of the lab sheet, I would like you to be able to start up a virtual machine that has been created by your student admin user, and it can be run by your normal student users through that. The VDC view will be slightly different, so you will only be able to see the resources that the one admin user has actually allocated to that group of users. So if you want to play around a little bit, you can take the permissions away from the CentOS DVD image, so that anybody that's in the group of students cannot actually see that image itself. So then when you go into the VDC view, when you log in as student admin, you'll see that you can see the vPrometheus 0 image, but you cannot see the CentOS DVD image. So if you create a virtual machine, it will not actually have the DVD available for you to use. All right. Remember though, the virtual machine is already built, so that the image contains the operating system, so the virtual machine will be bootable and will work even though you don't have the DVD template, the DVD image in the template, yes? And then when you change onto the VDC admin, you'll be able to create your own new users. You'll be able to create students, with their own student names and everything. They will all belong onto that same group that you are administering, and you'll be able to give them individual rights and permissions on what they can and what they cannot actually use on the system. And then finally, when you log in as a normal user, you should be able to simply see a virtual machine, click on it, and let it start and get it to actually run. Once it runs, you should be able to see some statistics, some graphs of the virtual machine running, so how much CPU is using, how much memory is using, and so on and so forth. You should be able to start up the virtual machine, click on the little blue VNC icon, and that will start the virtual machine on another tab, and you should be able to run and actually log in and use the virtual machine that has been given to you. Very important for this, in order to run an instance of this virtual machine as either a student admin or as a student user, the virtual machine must not be instantiated while you are logged in as one admin. Yeah? So before you go and play around with the groups and log in as VDC admin, so log in as student admin and so on, you need to go into your running VMs and terminate the virtual machine that you started as one admin. This is because the hard drive is persistent, so it can only be run and used once. Okay, if you create the hard drive that's not persistent, and you could start multiple images of that, multiple versions of that template, then you can have multiple users use that virtual machine while you have multiple, basically, instances of that virtual machine. Okay, so make sure you shut down any running virtual machines and that they disappear completely from the running VMs in one admin before you actually go into your student users and try to start up the virtual machine there. All right, so once you do get the virtual machine running as a normal user, that's the end of this lab sheet as well. You will hopefully have created a group, given it some permissions, and figured out how to basically manage some users as a cloud administrator in your own little virtual data center. Okay, the next lab sheet after that will be some slightly more complicated networking configuration, so you can have multiple network cards bridging us to the outside world. And then after that, the last lab sheet is to create a bunch of virtual machines that is essentially a little cloud in our little company or university really, and then you can have those users that you created here own and use those virtual machines in the cloud, get some services offered from them, and actually have a working cloud in its simplest form really, working in your computer. Okay, any questions about all this? All right, thank you very much.